What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today, this is an unconventional time to live stream, but I haven't been live streaming for the past 2 days, so I need to do this while we're doing it. But anyway, yeah. So what we're gonna do is we're gonna do something different. We are actually going to do a bunch of problems for 4 hours because I feel like I haven't actually been practicing my skills. So I'm not actually gonna do a virtual contest. I'm actually going to just do a bunch of practice problems that this code drills that they pick the problems that I have issues with, and then I try to solve them. So I'm gonna do some practice problems. So I might actually do. Let's see. Can I do this? Maybe I do a mini contest. Let's see. Let's see what rank is this. Okay, so 1,100. Okay, so yeah, I might actually do these problems instead. Let's see. 1,100, 1,700. Okay, that's a little bit harder, but let's see. Maybe I'll just do medium problems, actually. 900, okay. Yeah, I'm just going to do medium problems, actually. So, yeah, I'm going to basically be solving a bunch of problems and trying to figure out how to do it. And, yeah, we're going to try. Let's see what we could do, and let's see how far we could get up with, okay? So, let's start with this problem. Fridge lockers. There are n people there. Each have a private fridge. There's n fridges. Okay, each chain connects two different fridges and is protected by a lock. Okay. The owner of a fridge knows the passcode of all the other chains. A fridge can be opened only if all the chains to it are unlocked. If all the chains connected to it are unlocked. So if all these are unlocked, then it's, for example, the fridge has no chains connected to it at all, then any of n people can open it. Okay, that makes sense. The weights of the chains are A1, A2 to A of n. To make a steel chain connecting to fridge UV, you have to pay AU plus AV dollars. Okay, so if we connect two chains together, we have to pay the weights combined. Okay. Note the landlord allows you to create multiple chains connecting different pairs of fridges. Okay, that's true. Okay. Now the Hannah's apartment wants you to create exactly M steel chains so that all fridges are private. Fridge is private if and only if among n people living in the apartment, only the owner can open it. Okay, so in other words, fridge I is not private if there exists the person I not equal to J, such that the person J can open the fridge I. For example, the picture of all the fridges are private. On the other hand, there are n equal 2 fridges. Only one per chain which connects them both. Fridges are not private, which can only be used on another person. Okay. Of course, the landlord wants to minimize the total cost of all steel chains to fulfill his request. Determine whether there exists only any way to make M chains. If yes, print the maximum solution that optimizes the cost. Okay. No solution, put -1. Otherwise, print single integer c, the minimum cost of the ith of the next m lines containing u and I and vi, meaning that the ith chain connects two fridges ui and vi. Okay. Let's read in the test cases first, and then we'll try to see. Let's do this. Maybe I should create a Discord. Do you guys use Discord a lot? Hi guys. How you guys doing? Canal. Okay, let's go back to this problem. So now let's read in. So we have the fridges, and we want to minimize the cost. Okay, so fridges are A1. To make a steel chain category, you have to pay AU. You want to create exactly M chains so that all fridges are private. It's private if among n people living in an apartment, only the owner can open it. So the fridge I is not private if there exists an I and J, which the person J can open the fridge I. So what does that really mean? Wait, hold up. Each chain connects to two different fridges protected by a lock. The owner of the fridge knows the passcode of all the chains connected to it. The fridge can only be open if all chains connected to it are unlocked. If a fridge has no chains connected to it, then any of the people can open to it. So the owner of a fridge knows the passcodes of all chains connected to it. And that's only if, let's see. Okay, I'm going to read in the test cases first, and then we'll talk about it. So we have T test cases, right? For each test case. Yeah, the number of test cases. Each line is N, and M, so we're going to read in N and N. So let's do that. The number of people living in the Hannah's apartment, the number of steel chains that the requires respectfully. Second line is N integers the weights of all fridges. Okay, so let's create the weights of all fridges. I just call it A. Make it faster. Should we index it from 1? Yeah, they're indexing it from 1, so I'll just do that. Okay, so we read that in. Actually, this could be an integer because it's only 10 to the 4th. Okay, let's see. Weights of all the fridges are AU to the N. To make a steel chain connecting U and V, you have to pay AU plus AV dollars. Okay? So, okay. Note the landlord wants you to create multiple chains connecting the same pairs of fridges. It allows you. Okay. Let's see. So you want to create M steel chains so that all fridges are private. So what does that mean? It's private if among N people living in the apartment, only the owner can open it. So no other person acting on the loan can do it. So the fridge I is not private if there exists the person J such that I is not equal to J, that the person J can open fridge I. I'm still trying to understand the question. Okay. You want to minimize the cost. Okay. M chains. So if a fridge, hold up, you want to create M chains so that all fridges are private. A fridge is private if among N people living in the apartment, only the owner can open to it. How do I know if the owner can open to it? Fridge I is not private if there exists a J that some other person can open it. So how do I know that someone can open it though? That's a big question. So the owner of the fridge knows all the passcodes connecting to it. The fridge can be opened only if all chains connected to it are unlocked. For example, if a fridge has no chains connected to it, then any of N people can open it. So the fridge can only be opened if all chains connected to it are unlocked. All chains connected to it are unlocked. So we want to create, is it possible to create M chains so that all fridges are private? And a fridge is private if only among N people living in the apartment, only the owner can open to it. So no other person can open it. So that means the fridge I is not private if there exists J. So if only the owner can open it, what does that mean? So the owner can only open it if if it's unlocked, right? So the weights are here. Hold up. A fridge can be opened only if all chains to it are unlocked. How do I know if a chain is unlocked? If a fridge has no chains at all, then any n people can open it. But did I ever talk about unlocking? One, two, four, three, 3, 2, 4, 1. Okay, but you know what? We're going to look at the test cases and we're going to draw this out because I don't understand. Let me see. Okay. All right, I just got my pen. Let's go to sketchbook. We're going to do this for 4 hours. Hey, thanks. The sound is better. Okay, so we have 1, 2, 4, 3. Okay. So we have 4. Okay, so 4. Okay. 4, 4, 1, 1, 1, 1. So let's see. We have 4, 4. This is N, and this is M. And we have 1, 1, 1, 1. Thanks for the sound. Thanks for telling me about the sound quality, by the way. 1, 1, 1, 1. And then, okay, so now these are the weights of all the 1, 1, 1 is the weights of all the costs, right? Okay. So now they said that if you were to do 1, 2, 4, 3, 3, 2, 4, 1, you're supposed to do 1, 2. Okay, so now they say connect fridge 1 to 2. So let's say I have a fridge here. 1 to 2. 4 to 3. Okay. 3 to 2. Okay. 4 to 1. Okay. So let's see, why does this work and not anything else? So you want to create M chains. So we want to create, okay, so we want to create 4 chains, right? So we want to create 4 chains such that all fridges are private. Okay, a fridge is private if and only if among n people living in the apartment, only the owner can open it. So only the owner can open it. So if it was fridge 1, does that mean fridge 1 can open it? Only fridge 1 can open it? If I was in fridge 1, let's see. Fridge I is not private if there exists a person J such that person J can open the fridge I. For example, in the picture, all the fridges are private. Why are all the fridges private? Only the owner can open it. If there are n equal 2 fridges, only one person which connects them both fridge are not private. Both fridges can be opened only if by the owner, but also by another person. So if there are n equal to 2 fridges, and there's only one chain which connects them both, then both fridges are not private. Both fridges can be opened not only by its owner, but also by another person. The owner knows all the passcodes of all chains connected to it. Fridge can be opened only if all chains connected to it are unlocked. So all chains connected to it are unlocked. So if I were to do unlock this and this, right? One would be unlocked, right? then if I were to unlock this and this, 2, 3, and 4 would be unlocked. Because all chains unlocked are unlocked. But let's say I have n equal to 2 fridges. So in this case, it's this. And I were to unlock this. Wait, hold up. If I were to unlock this, what did they say? They said that both fridges can be opened by not only by one person, but by another person as well. This would be unlocked by one person, but also 2 people become unlocked. Wait, but that's the same thing over here, though. Because if I unlock these 2, 1 is free, right? If I unlock 3 and 4, these 2 chains, 3 is free, and then 2 and 4 are free. So wouldn't that mean... Oh, okay. 2 and 3 and 4 are free, but that's the same number of people that are unlocked, right? So if in this case, if I have 1 and 2 and I unlock this, both of these 1 and 2s are now free. These fridges are freed. So that's... Wait. That's greater than the number of fridges. No, that's greater than the number of chains. Hold on, I have to read the question again. I'm not understanding. You pay... Okay, I understand you have to pay AUV. You want to create M chains so that all fridges are private. A fridge is private if and only if among n people living in the apartment. Among n people living in an apartment. So among 4 people living in this apartment, only the owner can open it. No other person acting alone can open it. In other words, if fridge I is not private, if there exists a person J that can open fridge I. In the picture, all fridges are private. Okay, so here all fridges are private. Why are they all private? So let's say I draw this fridge 1, 4, 3, 2, and there's 1 connecting to 4. So if I do 1, 4, 3, and then there's another 1, 2. So why are all these private? Let me just, that was not a good drawing here. Yeah. Okay. Why are all these private? That's a big question. Okay, so all fridges are private because a fridge is private if and only if among n people living in an apartment, only the owner can open it. So so let's say I unchain this one, both of these two. 1 is now freed. So 1 is freed. So 1 is unchained. If I unchained 2 to these 2, 2 is unchained. So now 2 is unchained. If I unchained 4, no, but then 4 and 3 are unchained at the same time. Not understanding. Wait. Okay. Let me see the chat. Let's see. The question is fridge lockers. It's round 601. So if each steel chain unchains connects 2 different fridges and are protected by a digital lock, the owner knows the passcode all connected to it. A fridge can be opened only if all chains connected to it are unlocked. Okay, I understand that. For example, if a fridge has no chains connected to it, n people can open it. Okay, I understand that. Hannah's apartment landlord asks you to create M chains so that all fridges are private. Okay? A fridge is private if and only if among N people living in the apartment, only the owner can open it. So the fridge I is not private if there exists a person J. I is not equal to J, such that the person J can open fridge I. I'm trying to think. I don't understand what they're trying to say. If I do 2, 4, 3, 3, 4. Do they want us to... No, okay, I don't think it has to do with cycles. I don't know. Let's see. Let's see what does the chat thinks. What do you guys think? Such a tough problem. How are you guys? How are you guys? Let's see. Let's think. Let's think. Okay. On the other hand, if there are 2 fridges and only one chain which connects to them then both fridges are not private. Both fridges can be opened not only by the owner but by another person. I don't understand. If I have 2 people here, this is one person, this is another person. I open this fridge. Both of these are now opened, right? That makes sense. But in the case of this scenario, 1, 4, 2, 3, like what they said in the example, right? 1, 4, 2. This is what they wrote in the example, right? 1 connects to 4, 4 connects to 3, 3 connects to 2, 2 connects to 4, 1 connects to 2. If I were to unchain these 2, 1 is freed, right? So this is freed. If I were to unchain this 2, yeah, 2 and 3, then 2, these 2, then 2 is freed, right? But then I'm still going to get it back up to the same situation of here, though. If I unchain 3, 4 is still going to be, I'm still going to have 2 more. Like if I unchain this, that's still 2 more people that could unchain from each other, though. How is this, how's 4 and 3 unique for their fridges? That's what I don't get. Like if I unchain this, these 2 is unchained over. Yeah, that doesn't make any sense. How are all the fridges private? Among N people living in an apartment, only the owner can open it. No other person acting alone can open it. Okay, so let's say we have 1, 2, 3, 4 people in the apartment. I unchained the first one. Wait. Wait, are they saying each person can only unchain one chain? Is that what they say? Only the opener can open it. Fridge I is not private if there exists person I not equal to J, that J can open the fridge. For example, in the picture, all of them are private. On the other hand, if there are N equal to 2 fridges, only one chain which connects them both, then both fridges are not private. I don't understand. don't understand the problem. And fridges and chains. Hold up. Both fridges are not only by the own. Since the landlord wants to minimize all the costs, there's only one way to make it. End chains. This is really difficult. It's not okay. It's not even difficult that I can't find a solution. I don't understand what they're saying. That's what these problems are like. You live in a shared apartment. There are n people. Oh, including Han. Okay. So there's n people including Han. Each have a private fridge. N fridges are secured by several chains. Each chain connects two different fridges and is protected by a lock. Okay. The owner of the fridge knows the passcodes of all chains connected to it. A fridge can only be opened if all chains connected to it are unlocked. For example, if a fridge has no chains connected to it at all, then any n people can open it. Okay, so if I have... Okay, so we don't... So there's one thing we need to know. Okay, so just from reading that, there's one thing we need to know. We cannot have just one fridge that there's no chains, because that means anyone can open it, right? It's not locked, right? And that's bad. So we can't have just one free fridge without any chains. So that's one thing, right? Let's see another thing. If only the owner of the fridge knows the passcodes of all the chains connected to it. So only the owner of the fridge has the passcode. So if one's chains are unlocked, 2 and 4 are still locked. 2, 4, and 3 are still locked. Right? So if I do... So for 1, if I get rid of these two chains, right? 1 is unlocked. Only 1 is unlocked. And 4 and 2 and 3 are not unlocked. They're still locked. If I get rid of these two chains, because I'm 2 has access to these two chains, so I get rid of these two. 2 is unlocked, and 3 and 4 are still locked. If I'm at 3 and get rid of this chain, 3 is unlocked, but 4 is also unlocked. What if one person gets rid of one chain? Like if I get rid of... Okay, let's say I'm at 1 and I get rid of one chain, this chain. 1 is still unlocked, right? If I'm 4, I get rid of this chain. 4 just unlocked 1. Okay, so 1 is unlocked. What if I'm at 2? And I unlock this chain. Well, 2 is still locked. 4 is unlocked, right? If I'm at here, I unlock this chain. 2 is unlocked, but 3 is still locked. 3 and 4 is still locked. Oh, but that still gets you. If I unlock this chain, 3 is going to be unlocked and 4 is going to be unlocked, though. Right? Because they share the same chain here. What do they mean? Why is this fine? Like, if I get rid of these two, 1 is unlocked. If I get rid of these two, 2 is unlocked. If I get rid of these, get rid of this, 3 is unlocked, and 4 is unlocked, though. Okay. So that's 4 chains unlocked. How would I do this? arbitrary number of chains can be between a pair of fridges. If there's multiple answers, print any. 3, 2. Let's look at another. Okay, let's look at another case. Maybe if we keep going back, if we keep looking, we'll find out a pattern for why this works. And I don't know why I just did this, but that was such a weird. What a weird. Whoa, whoops. I'll just clear the whole thing. Let's look at this test case 3, 1, 1, 2, 3. Let's look at that. 3, 1, and 1, 2, 3. So if I have 3, 1, my gosh. 3, 1, and 3, 1 is this is n, and this is m. So we want one chain? Okay, that's weird. 1, 2, 3. And what does that give us? 3 and 1, 2, 3. Does it give us -1? Yes, that's going to give us -1 because 1 is going to be opened by anybody. It's not locked. So that makes sense. So if our m value is, if the number of chains is less than or equal to n minus 1. Oh, if it's less than n minus 1, right? Because we need 3 chains first in order to make sure that it's works, right? We need at least 3 chains to make sure everyone's chained, right? So if it's less than n, you should put -1. From my understanding. So for that, I'm going to do this. If m is less than n, I'm going to print C out -1 and then continue. So if m is less than n, I'm going to C out -1 and then continue. Okay, how long have I been live streaming? I feel like, oh, it's been 30 minutes. Holy crap. Okay, that's bad. All right, after another 10 minutes, I think I'm just gonna take my losses. Because after 40 minutes, if I don't understand, then I'm just gonna take my losses. Okay. Print -1. Okay. Let's see. 3, 3, 1, 2, 3. 3, 3, 1, 2, 3. Okay, so if I go 3, 3, if I do 3, 3, n and m, 1, 2, 3, and I have 1 and a 2 and a 3, and I connect these two together, three to 2, 1 to 2, 3 to 1, 3 to 2, 1 to 2, 3 to 1. Yeah, then I get, yeah, the can we just connect any of them together? Print 1, 2, 4, 3, 3, 2, 1, 4, 1. Make sure there's a cycle. Because this is a cycle. What if I just connect all of them together and then just, for one of them, keep a cycle? Let's try that, actually. Okay, so let's look at 4, 4, 4, 1, 1, 1, 1. So let's look at 4, 4, 1, 1, 1, 1, and then we have 1, 2, 3, 4, and they put 1 to 2, then they put 4 to 3, then they put 3 to 2, 3 to 2, then they put 4 to 1. Wait. 1 to 2, 2 to 3, 4 to 3, 2 to 1, 4 to 1, 1 to 2, 4, 4 to 3, 3 to 2, 4 to 1. So there is no cycle. No, but we have cycles for 1, 2, 3. If I get rid of 1, I get rid of these two. This is... Only the owner can free... In the picture, all the fridges are private. On the other hand, if they're... A fridge is private if and only if among n people living in the apartment, only the owner can open it. Oh, okay. So if only the owner can open it. So okay, let's say I'm here, right? 1, 2, 3. And I get rid of these two. So 1's owner got rid of these two, right? But then here I'm at 3. Wait. 3's owner, if I do get rid of this chain, 3 just saved his chest, but 2 saved... But 2 didn't save. Okay. I have no idea. I have no clue. Okay. So let's just for our sake, how about we just like... Yeah, I have no clue. I have no idea. Let's look at the tutorial. I have no idea. Let's see. Where's the chains? Fridge locks. Okay. You're modelizing the graph as a problem as a graph where each fridge is a vertex and each chain is the edge between two vertexes. The problem is now equivalent to, given a graph with n vertexes has a value a of I, we want to add m edges such that each vertex is connected to at least 2 different vertexes and the total cost of edges added is minimum. So the total cost of edges added is minimum, and the cost of a edge is the sum of value of its 2 endpoints. So if we're going to do this, we need to observe some basic properties of graphs. So now each edge added will increase the sum of degree of all vertices by 2. So adding m edges will make the sum of degree equal to 2 times m. Since each vertexes must be connected to at least 2 other vertexes, the minimum sum of degree is 2 times n. So if in this case it is obvious that the answer is -1. So if we do basic properties of the graphs, so we want to add m edges to the graph such that each vertex is connected to at least 2 different vertexes and the total cost of edges added is minimum. We want to add m edges to the graph such that each vertex is connected to at least 2 different vertexes and the total cost of edges is minimum. The cost of an edge is the sum of value of its 2 endpoints. Observe some basic properties of graphs. Now, each edge added will increase the sum of degree of all vertexes by 2. So adding m edges will make the sum of degree equal to 2 times m. Since each vertex can be connected by 2 other vertexes, the minimum sum of degree is 2 times n. 2 times m is less than 2 times n, which means m is less than n. In this case, answer is -1. Yeah, so that's what I did that. This case would work, right? We did -1 if its m is less than n. So that was an observation. Second case, 2 times m is equal to 2 times n, so m is equal to n. In this case, it is easy to see that the degree of each vertex will be exactly 2. As a result, no matter what edges we add, the result is still 2 times the sum of all of the numbers. Oh, okay. Okay, I get it. So I get it. I get what they're saying here. Okay, so if we have 3, so let's say in this case 1, 2, 3. If I were to add an edge between 1, 2, 2 to 3, and 1 to 3, right? This is going to give me, so because the number of edges and the number of nodes is exactly 1 to 1, the ratio is 1 to 1, so I'm going to add an edge to all the nodes connecting them to each other, right? So then if I'm going to do this, connecting all the nodes together, I'm just going to connect each node to each other. So that's going to be, if I'm going to connect 1 to 2, that would be a of 1 plus a of 1 plus a of 2, right? A of 1 plus a to 2. And then if I'm going to connect 2 to 3, that's going to be a2 plus a of 3, right? These are the weights, remember. a2 plus a of 3. And if I'm going to do 1 to 3, that's going to be a1 plus a of 3, right? So if we're going to connect all the nodes together, it's just going to be the sum of all the weights times 2. So that's what they're saying over there. So so we could just do that. So if m is equal to n, which, wait, I didn't even read in the numbers yet. Okay, so right here, we could do if n is equal to m, then what we're going to do is we are going to take the, we're going to just pair up each edge with each other, right? So that's what we're going to do. So we're going to do, we're going to do like 2 times a1 plus a2. So we're going to do cout. So we got to sum up all the numbers. So we're going to have to loop from 1 less than equal to n, I plus plus, and then we're going to have to sum up all the numbers. So we plus equal a of I. So that's what we're going to do. Okay, and then we're going to do cout 2 times sum. Now we need to pair them up. So if we're going to pair them up, in this case of n equal to m, we have to pair up 1 to 2, 2 to 3, and 3 to 1. So to do that, we just have to pair up each number. So that'll just be 2 to 3, 3 to 1. Okay, so that's just, we just loop up all numbers up to the last array value. So if we're gonna loop all the nodes. So we have 3 nodes, right? 1, 2, 3. We just have to loop from the first node down to everything except the last node, right? And then we pair the last node to the first node, right? So while we're looping first to the last, we're gonna pair up the first and second to third, stuff like that. Okay. What if we get, wait, okay, so there is an issue with this. What if I have like an even number? So what if I have like 1, 2, 3, 4? If I pair 1 to 2, 2 to 3, 3 to 4. Oh no, that's fine. I just pair 4 to 1. Okay. Yeah. Okay, so yeah, so that's what we're gonna do. So from here on, we're gonna pair the first. So we're gonna go through the number of nodes of n. We're gonna go to the last, pairing it up, except for the last one, right? And then we're gonna pair up I with I plus 1. The first node, each node with the second node, and then we are going to actually second with third, third with fourth, fourth with fifth. Yeah. Then after the n, we'll just pair up n with 1. Okay? So I think this would work for in the case of n is equal to m, right? So if the number of nodes is equal to it. So we'll do that. Let's do another problem after this, by the way. Let's test it out, actually. So let's do one test case, and then if we do one test case, and do 3, 3, and then 1, 2, 3. So if we do like one test case, 3, 3, and then 1, 2, 3. Okay, so it should pair 1 to 2, 2 to 3, 3 to 1. Okay, let's try one test case, 4 to 4, and then it should do 1, 2, 3, 4. 1 to 2, 2 to 3, 3 to 4, 4 to 1. Okay, so that's right. Okay, so that's good. Now let's think about the other case where they said of the original pre-modified version of the problem, 2 times m is greater than 2 times n, which implies m is greater than n. So if n is greater than n, let's see. If we have to add m such that the cost of it is the sum of its two endpoints. So if n is equal to 2, then the answer would be -1. Why is it? Because for each vertex, we have at most one different vertex to connect to. We have only one different vertex to connect to. So the problem isn't about given n vertexes, each vertex has ai greater than 0. We want to add m edges to the graph such that each vertex is connected to at least 2 different vertices. So each vertex is connected to 2 different vertices, and the total cost is minimum. Okay. What about the case when it's greater than? So what if I have 5 vertexes and we want 5 chains? So what if I have 5 vertexes, 5 chains? Oh no. Okay, what did they say? What was another problem statement? Let's see. What if m is greater than, hold up. So I know that if m is less than n, it's impossible. If n is greater than m, is that impossible? So if I have like 2 and then I want 3 chains. So I have 1, 2. Oh no, if it's 2 is impossible. Okay, let's say 3 chains and I want 4. That was a bad drawing. So if I have 3 and I want 4 chains, so I have 3 nodes, 1, 2, 3. I want to connect them 4 nodes, but each of them has to connect to at least 2 different ones. Is that possible? Okay, hold up. I should put this my -1 down to here. Yeah, I should put that here. Okay. What do they say if it's greater? Let's just submit it and see what happens. Wrong answer on 3. Okay. if -1, -1, -1, -1, -1. N is equal to 2. One, 2, 3, 4, 2, 2. 1, 2, 2, 1. 1, 2, 2, 1. So if I do, let's see, 1, 2, 2, 1. If it's less than, if m is less than n, if m is less than n, yeah, wait, that's what I did. M is less than n, it's -1. But the case where it's not, participants output 1, 2, 2, 1, 52. 2, 2, 4, 3, 2, 2. 4, 3, 2, 2. 4, 3, 2, 2. I don't know. It's beyond my understanding. If 4 is equal to oh yeah, we also have to do or n is equal to 2. Yeah, then it's not possible. Let's try submitting it again. Oh, that was it. Wow. Huh. They didn't ask for if m is greater than n? Wow. Okay. So yeah, the problem boils down to, can you connect a vertex with at least two different others, right? And the total cost is minimum. Okay, well that was a fun understanding of a graph problem. Whoops. Let's do another problem. So this problem was fridge lockers. It was round 601, division 2B. Let's do another problem. Let's see. What was I did fridge lockers. Let's do circle lane. I think this is a geometry problem. Oh, this is 8. Okay, so this is only 800. Okay, so this is not going to be that bad, but it helps you improve your speed. Let's look at another. We'll do an A problem. Okay, we'll do greedy next. Mr. Greedy. Let's see. Maybe we could do after that. Let's do. We could do brute force sugar. Yeah. I'm gonna refresh this. Okay. So if you guys don't know, Code Drills is actually a good tool you could use to improve your skills. Okay. All right. This is math implementation. Let's see what we could do here. Okay. The circle of a subway has n stations. We know the distance between all the pairs of the neighboring station. D1 is the distance between 1 and 2. D2 is 2 to 3. Blah, blah, blah. Dn is between 1 and n. Okay. The train goes in a circle along in both directions. Find the shortest distance between the stations with numbers s and t. You just have to keep going in. Hold up. I think all you can do is actually just go in a circle. Because if it's in a circle, there's no other path you could go. Right? Like if I have... the first one is... so if I have 2, 3, 4, 9, and these are the distances. So D1, D2, D3, D4. The D4 goes back to 1. And then I have like... Let's draw it as graphs again, okay? This, 2, 3, 4, right? D1 is 2, D2 to 3 is 3, D4 4, 9. And then you want to find the minimum distance between S and T between 1 and 3. Between 1 and 3, you just have to loop through from 1 to 3. You could either loop through 1 to 3. Wait, so we could loop through 1 to 3 through the right direction or the left direction. So, let's see. Can we, okay, so we could go in both directions. Okay, so what we're going to do is we're going to loop through from 1 to 3. We want to find the smallest distance. You would just loop through from 1 to 3 this way or 1 to 3 this way and then compare the distance. So, yeah, you just have to add up the numbers. Yeah, you just have to add up the numbers from 1 to 3 and then 3, 4, 1. So we'll have to loop from 1 to 3, not including the distance of 3. Then we have to loop from 3 to 1 and then add up those distances. 3 to 1, and then we don't include 1. Okay, so let's do that. So we have T of n. Okay, let's see how fast it would take for us to. So the first one's n. So we don't actually do this. We're gonna loop. Okay. No. CNN vector int d n. Then we're gonna loop through from 0 to n, and then we're going to read in d of. Okay, now we are going to so we're given s and t, so we're gonna actually subtract s and t by 1 when we read them in, because we are indexing from 0, and it's much easier to do it from 0. So we're gonna read in s and t, and then we're gonna subtract s and t by 1. Okay. Okay, so now we're gonna have to travel to the right of s and then travel to the left from s to t. Okay, so for I equals 0, I is less than s, I plus plus, sum let's do left sum. Left sum is going to equal to left sum plus equal to d of I. So that's going to add up all the numbers this way. So it'll be 2 plus 3. Then we have to start from st1 is s. We have to start from t and then keep going right and loop until we got to s. To do that, we actually have to do while t is let's do start I equals, let's start a counter index 0. This is going to equal to s actually. While index, t, actually it's better for t. While index is less than, is not equal to s, right? We're going to do index plus plus. So this is going to keep going to the right. But then we have to mod by the amount of numbers, so we have to do index plus 1 mod by n. So this is gonna make us go back into a circle. So if we have 1, 2, 3, go to 4, it'll go after 4 it'll go back to 1, right? So that's what it's gonna do. So that, yeah, and then we're going to do right sum, and then right sum we're gonna do right sum plus equal to d at index. Okay. Why can't I do this? Overflow. Index is equal to t though. T is long. Okay, let's make t an int. now it shouldn't overflow. Okay, I don't know. I don't think it matters for now. Because we're modding by n. Okay, so ideally this should work, and then we should need to print out right sum and left sum. Okay? So this question is circle Codeforces round 170A. Let's test if this works actually. Why can't I do this? Oh. Damn. Why did I make it capitalized? That's just annoying. Okay. Let's do this. Okay, we got 0. That's not right. Why is it not right? 0 to 2, 0, 1, 2 should sum up to 5. I don't know why it's not. Okay. So I think it has to do with right index. Let's see. Okay, so we're at right sum. Right sum at index of 2 is going to be 4. Right sum at index 3. Okay, so this is doing 4. It's going to add 9. It's going to add 9. Yeah, so 4 plus 9 is 13, so it does 4, 9, 13. It should go to 2, and it should stop. Yeah, okay, so that's good. Now we have 14. Okay, left sum is 0. I don't know why left sum is 0. Loop from I is 0 less than s. What is s? Crap. Okay, yeah. So s is starting at 1, and we need to start from s and go to t. So we actually have to start from s and go to t. So yeah. Now it's 5. Okay, so I think that's right. Let's try the other test cases. 0. Why did I get 0? That's wrong. Okay. So I got 0 because left sum 3. 4 is less than 1. Okay, so what we need to do, we need to swap the smaller value so we could start at the lower value first, lower index, right? So yeah, we need to swap s and t. So we start at the lower index and then go to the higher one. So let's see, if s is less than t, swap s and t. Yeah, that would be it. No, if t is, if s is greater than t, swap it. Yeah. What am I doing? Okay, that's wrong. I didn't copy it. 15, yeah, okay, so that's right. Let's see. What else? Try this one. Try to get in a habit trying to AC in one go. 1 is right. Let's see this one. It should give us 0. Yeah, okay, that's right. So this should be right. We might look at the editorial just to see if there's a faster way to type it out. But I think this should be right. Yeah, I got AC'd. Okay, so that's good. Okay. We need to, let's look at the editorial to see if there's a faster way to do it. I don't know where it is. What was the problem? Circle lane? Do they even have it? Circle line. This is not I think this is Division 1. This blog's for Division 1. Okay, so yeah, this doesn't correspond to the same problem. All right, whatever. Okay, let's go to the next problem. So, yeah. Okay, so this is a little bit harder, but let's see if what we could do. Okay, Appleman and card game. Okay, Division 26, round 263. Given N cards, each card has an uppercase letter on it. You have to choose K cards from... Okay. I hope it's not a permutation problem. You need to choose K cards from the cards. Then you give the coins depending on the chosen cards. For each of the I card, you calculate how much cards have the letter equal to letter I. Then sum up the qualities. Such a number of coins should give to Toastman. What does that even mean? Okay, so let's read in N and K, and then read in STR, the string. So let's do that first. I'm going to clear this. Okay. So they said N and what did they say? N and K. So read in N and K. N and K. And then let's read in S. Okay. N, each card has the uppercase letter written on it. You have to choose K cards from the Appleman's cards. Excuse me. Then give Toastman some coins depending on the chosen cards. Formula for each Toastman card. We should calculate how much Toastman cards have the letter equal to letter I. Then sum up those qualities. I don't understand. Letter equal to letter I. Let's see. How long have I been live streaming? I've been doing for only 1 hour. Okay. Well, I thought I would spend more time. Actually, it's only been 1 hour. That's crazy. Okay. I'm gonna get a drink of water before I come back. Okay, guys, I'm back. Okay, we have to choose K cards from the Appleman's cards. Then we have to give Toast guy with some coins depending on the chosen cards. For each card I, you should calculate how much cards have the letter equal to on the ith. Then sum up those quantities. Such a number of coins Appleman should give to Toastman. What is the maximum number of coins Toastman can get? Maximum number of coins Toastman can get. Let's see. If I were to... loop. Okay. In the first example, you choose 9 cards with the letter D. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah? And 1 additional card with any letter. For each card with D, he would get 9 coins, and for each additional, he gets 1. So, 1, 2... Hold up. 9, he would get 1. So, you have to choose K cards. So, I need to choose K cards from Appleman's cards. So, okay, so there's 15. Okay, so let's look at this. Let's look at the example. We have 15, and we have 10. This is N. This is K. Need to choose 10 cards from this 15. We should calculate how much the cards have the letter equal on the ith, then sum up those qualities. For each of the card I, you should calculate how much Toastman's cards have the letter equal to the letter on the ith. So each of the cards. So if I choose, okay, hold up. Okay, so this, okay, so the ith letter describes the ith card. So the next one is D, Z, F, D, F, S, K. Can I just type this out? I don't want to, might be a, oh yeah, I can. I can type this out, wow. Okay, so this is the next, this is the next information, right? I don't know why I can't edit this now. Okay, whatever. So D, Z, F, D, F, Z, D, F, D, 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 F. So for each of the ith card, we should calculate how much we should give. So if there's 9 D's, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 D's, and then there's 1, 2, 3, 4 F's, and then there's 2 Z's, right? So if I can't do it for draw for some reason. So there's 9 D's. There's 4 F's, I think. What did they say? 1, 2, 3, 4. There's 4 F's. There's 9 D's. There's 4 F's. And then there's 2 Z's, yeah. So that's just, I'm just counting up the number of characters. So you want to give coins to Toast depending on the chosen cards. So we have to choose 10 cards from the 10 cards from here such that the cards have the letter equal to the letter on the ith, then sum up those letters. The cards have the letters. What is their explanation? In the first example, you could choose 9 cards with letter D, 1 additional card with any of the letter. Each card of D, he would get 9 coins. An additional one would get 1. Each card with D, he will get 9 coins. Why? Each card of D, he will get 9 coins. So, oh, okay. So if there's, okay, so here, each card of D, he would get 9 coins because that's the number of occurrences, right? So then he would choose this K, he's going to choose 9 of them, and then you choose 1 out of this N, right? So out of here, we're going to choose 9 and 1. And then for these, for 9, we're picking 9 Ds, and then 1 with whatever F or Z, right? So that makes it 9 times 9 plus 1 times 1, which gives us 81 plus 1, which gives us 82. Okay? So let's go back to here. I think I get it. What if we just keep a track of a number of occurrences for each letter, right? And then we do the thing. But before we start getting too cocky, let's look at the next test case. YSNPI. So there's everyone's 1 here, right? In the first case, you could choose 9. Okay, so here everyone's 1, right? So then if we pick 4 out of 6, they're all just going to be the same, different characters. So that'll just be 4. Okay, so I have an idea how you would do it. You would keep track an occurrence of each letter or character. That you go through your string, keep track of the occurrence. Oh, excuse me. And then, yeah, keep track of your occurrences. Do the thing. Go through it. So if we're picking 10, we want to pick out the one with the most number of occurrences first, and then subtract whatever number from that. So if I pick 9, that has the most number of occurrences. Then I take 10 minus 9, I get 1. Then I'd pick out the next number of occurrences, which is this, and then go so on and so forth. So that's what I'm thinking you would do it, okay? And each time you do it, you multiply by the number of occurrences. So first we're going to get the number of occurrences. So for auto x and s. This is for every character in s. Let's use a map. So we're going to map a character with the number of occurrences. So this is going to be, you can use an array, right? But it depends on you. So here I'm going through every character and I'm just adding up number of times it occurs. Yeah, now I'm going to go from k. So now I want to sort it by value, right? So if I want to sort it by value, so I have a key now and a value for each character. And then I'm going to sort, after sorting from value, I'm going to drop my k and just keep subtracting by the number of occurrences. So yeah, that's what I'm planning on doing. Let's see, does maps sort by value? That's a big question. Let's just see what it does actually. So if I do 15, 10, 20, df, k, whatever, this, right? Does it sort by occurrences? That's a big question. I think it sorts by keys actually. Ah, shit. Hold up, let me try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so this should be 6, 7, 8. Oh, so it does it sort by occurrences? I don't think it does. I think it sorts by alphabetical order. Yeah. Let's see. Sort by most frequent. How to sort maps by value in C++. Oh, this is going to say to push it all into a vector and then... No, I don't want to do that. I don't want to use multi-map. Yeah, I don't want to do that. I don't want to do that. You could do that, but I don't want to do that. Oh, that's annoying. Oh, that's super annoying. Okay, so we can't actually do that. So what we're actually going to do is actually pair them up. That's actually super annoying. Okay, so maps can't do that. Not that I recall, you can't sort by value. So we're actually not going to use a map. We're going to use a vector and a pair. So I'm going to pair each character with equivalent value. So this is going to be occurrences. So here what I'm going to do is I'm going to do occurrences at... I need to do... I have to get the pair at the... Okay, hold up. Oh boy. Okay, you know what? I got a better idea. Okay, we're gonna put in a map and then we convert it into a pair. Okay, so here, so now I could go through the map and then just push the pair into another vector of pairs. Occur sort. Okay, there. I put it in like that. For every auto crap. For every, how do I, okay. Let's go back to here. Pushback. Okay, I got it. So we have to push back. Okay, so for every auto ampersand x, so for every value, key and value inside occur, we're gonna push back occur sort dot pushback x dot first, x dot second. I think so. Yeah. Okay. Oh wait, actually we could just do x. We didn't have to do that. Okay, whatever. Okay, so now we have that. We have to sort it by using this comparator, so let's do that. So sort, and then we need to create a Boolean function for comparator. So they're using templates here. Let's see. I don't want to do that. Okay, I'll just create a Boolean. I'll just copy this. Okay. So this is another function. Oh Lord. Okay. Bool compare comp. No, I don't need this. I don't need this. Const t. Okay, I don't need it. This is gonna be pair. Yeah, pair. Pair char int. They should have like, I don't know. Whatever. Okay, s dot second. If it's not equal, just return second. Let's return first. Okay, so this is gonna sort it by second pair. Okay, once it's sorted by that, let's do occur.sort. So once I sorted by a number of occurrences, I'm gonna go through k. So then multiply, then I'll sum it up. And then after I'm done summing it up, I'll just print it. Okay, so I'm gonna go through every k. So now I'm gonna go through k. I'm gonna do 10 minus the max number of occurrences first, and then continue doing it, so on and so forth. So while k is greater than 0, k minus equal to occur sort at beginning. I don't know. Most frequent minus 1. Ten minus 9 gets me 1. 1 minus 1 gets me 0. Ten minus 9. Let's see. Yeah, Codeforces is pretty nice. So I'm solving for 4 hours today because I haven't been practicing at all. That's the reason why I'm solving for 4 hours. It's only 1 minute 20:30. Huh. I have not been practicing at all, so that's why. So occur sort. Okay, so we need to subtract. So we're gonna subtract 9 from 10, and then continue, and then 4 from. Yeah, so we're going to subtract. Okay, wow, okay, this is going to be difficult. So we have 10 greater than 0. We're going to subtract 9 from 10, and then that'll be 1. Then we'll go to the next one. 4 minus k minus the next one, so on and so forth. Okay, so we're going to do, this is going to be index starting to 0 at index dot second. Okay, so so now we're subtracting the second one, and then we add index for 1. Okay, so what we're going to do is we're going to multiply. We have to have a sum equals 0, and then we have to do sum plus equal to occur sort at index beginning, and then we get the first value and then multiply it. So we add by first value multiplied by itself, so that's going to be 9 times 9, I think. We got 9. Okay, and then after that, we're done, and then, yeah, it should be done. And we get 1, 2, 3, 4. Let's see. Let's see if this is right. Oh, I gotta see out some. Did I see out some? See out some. Okay, should give us 81. If it doesn't, then I don't know. Holy crap. That is a lot. 1,700. Okay, why did that do that? That's a big question. Why did that do that? Okay, so k is 10. Okay. So we want to do it by decreasing order, not increasing order. So, yeah, this should be greater than. It's still wrong. Okay, let's look at that. Something is wrong with our. Something is wrong with the way we're summing it up. So let's look at. Okay, so now it's D4 2. Okay. Okay, so k is greater than 0. We're going to sum up d's first times first. No, that's not what we should do. Sum up d's second times second. Okay, yeah. Okay. That's what we're supposed to do. So now it should give us 82. $97. Okay, that's not right. Let's see. Something with implementation problem. Here minus k. So we want. So what our code is doing right now is that it's taking 9, minusing by 10, and that gives us 1. And it was 9 times 9, which gives us 81. But then at 1, the next remainder, it doesn't do the remainder. It just does 4. 4 times 4, which gives us 16. That gives us 97. So what we want is we want to take the remainder after subtracting by most number of occurrences. So once you're done with the remainder, after it's done, you want to get the k. So you want k times 4. Actually, you just want. You just want 1. So after you get one character, you have to just multiply by itself. So we can't do it this way. Ah, I got it. If k is less than occur sort at index.second and break. So we don't want this. We want if while k is greater than occur sort at index.second, then we continue. Okay? Yeah, so while our k value, so we have k, which is 10, while if it's greater than the maximum occurrence, which is 9, we're going to subtract it and continue. Right? And then we have 1. Then we move it to the next value over here. And then we are like, okay, now k is less than it. So we're done. And then we just add by k by the end. So yeah, in the end, we'll just do sum plus k. Okay, so this should work now. Okay, so that gives us 82. Let's look at another scenario, 6, 4. Let's see if this works. 4, okay, so that's right. Okay, so I think this works. I'm not 100% sure though. So this is going to be oh wait, it's going to be unavailable from this time? At 5 p.m. Oh crap, Codeforce is going to be unavailable at 5 p.m. 5 p.m. to... No. Okay, so by the time of 5 p.m. 5 p.m. to 7:30. Dang, okay, so by the time that occurs, we should just solve problems at Coder. Okay? So when that time occurs, let's just solve problems at Coder. Okay, so what's the problem? What was the problem? Expected 13, found 11. 15, 9, 5, this here. Let's look at this. Expected 13, found 11. Okay. Why is it 11? That's a big question. So we're going to go here and we're going to... So we're done with that. Now we have... Okay, so we have 3, 2, 2, 1, 1, 1. What is our k? We have to pick 5. Okay, so if we're gonna pick 5, we have to pick j first. So that's 3 times 3. 9. 9 plus 2 times 2. So that's 3, 2, 3, and then 2. 9 plus 9 times 2 times 2, which is 3, 3, 3, 2, 4. It's gonna give us 4. Okay, so the first again 9 times 9. Sum should be 9. K is now 2. It should be greater than or equal to. So then it goes to the next one. Easy. Now it's 13. Okay, yeah. Yeah. So now let's submit it. Wrong answer. Okay, so what's the problem? 225, output 15. Let's try that. How you doing, Pavel? So it gives us 15, but that's not what they want us to do. They want us to do... Okay, so let's see. It's sorted by 46. Okay. So we need to pick 15 out of these. So 46 times... Ah, that's not right. Pick 15 times... What's 15 times 75? Is that what 225 is? 15 times 75. No, that's not right. 15 times 15. 225. Okay, so if we're going to do it this way, we have to do... Let's see. If we're going to do... Oh, what just happened? Okay, so at... they said at 5 p.m. we need to... we have to change it up. So... Yeah, I'm going to start doing @coder at 5 p.m. So I'll do that. Or maybe I could do... When @coder doesn't work and Codeforces doesn't work, you could do code chef. You could do code chef. I don't like code chef though. I don't like code chef. Too many people cheat on this. Lunchtime is in 4 days. Preparation for SE, but what is this? Excuse me. Okay, that's too much computer science-y stuff. Okay, so back to this. Okay, so what we need to do is, if it's greater, I got it. K multiplied by occur sort at index dot second. Okay, so if it's less than, we just do this. Actually, this is assuming k is less than occur sort dot index. That's second. Excuse me. Let's submit it. Ah, goddamn. Goddamn. Okay, we have to do if... So k is 15. If 15 is less than... Okay, I got it. If k is less than this... So in the beginning, if it's less than, we just do k times this. The number of occurrences, yeah. Actually, I don't know if this is actually right. Would it be k times k? Yeah, I think it would be k times k. Okay, yeah. Then let's do, return 0. So it should give us 225. Ah, crap. Let's just submit it. Wrong answer on 12. What's the problem? Why am I a bit off? How am I a bit off? Oh boy, this is kind of tough. Let's keep going, keep going. Let's see. What do we have? 44, 32, 14, 10. What is our K? Our K is 50. So it's going to do 44 times 44. And you're going to have 6 left. So 1936. You're going to have 6 left. So we're going to pick 1942. Ah, that's bad. Okay. You have 6 left. Six left. Multiply by the index. K plus. So if it's less than it, then we're gonna multiply C out sum plus K multiply count occur sort index dot second. Else we do this. So now it should give us the right one. Okay. Oh my gosh. Fungi. Okay. 2128. That's not right. What is K times occur sort? 6 times 32. That's 12, 190, 192. 6 times 192 plus. Ah, that's not right. How did they get this? All right, we only have 15 minutes left, so let's look at the tutorial. Okay, it's a simple greedy problem. It's not that hard. Choose K from the source. Total score is the number of A and K cards squared plus number of B K cards squared plus number of Z's and K cards squared. This value is maximized by the simple greedy algorithm. You take K cards from most occur. That's what I was saying. That's what I was doing. Take K cards from the most appeared character and N, the second most appeared character. I don't know what's going on. I don't know why I'm getting the wrong answer. Oh, wait. No, it's not right. K cards, so we pick 44. So we have 1936. Then we have 6 left, 6 cards left. $1936 should be 1942. Is that what it is? What is their answer? 1972. How did they get that? 6 from... Oh! 6 times 6. 36. My gosh. Okay. Okay, this, you just do 6 times 6. Oh, okay. Now it should work. Yeah. Let's look at other people's solution after this. Wrong answer on 24. Oh boy. I'm getting an overflow. Dang. Okay, that means I have to use long. Okay, I could do it. Let's submit it again. I have not been practicing at all. Let's see. Still, I use long though. What's the problem? Oh. Okay, wow, that's annoying. So I have to do long for int also. Okay, this I have to do long. This I have to do long. This I have to do long. Long. Okay. Now it should work. Wrong answer, 35. My gosh. How? How am I still getting overflow? Okay, I'm getting way too much overflow. Let's just look at one of their answers. Because I'm doing the same algorithm. Vision 2B. I should have done like next or something. I don't know. I did that. Okay. I don't get it. I'm doing that. I did long. K is less than... what if I make K long? Where's K? There's only 8 minutes until we have to switch gears. Not even sure if it crashed yet. Oh, okay, it didn't. Oh, now it got accepted. Yay, got accepted. So now let's look at other people's solutions. So this guy did it in six minutes. Yeah, so you can use an array. So that's what this guy did. Use an array. He sorted it. Went through the numbers. Okay. Found the minimum. I don't know what that means. Oh, minimum of k. Oh, then multiply. Oh, then subtract. Oh, that's it's more concise than mine, but keep track of every character. Sort it by decreasing, I think. Are they sorting by increasing or decreasing? Yeah. Oh, no. They sorted by increasing, and then they went from backwards. That's what they did. They went backwards, found the minimum k between k and the number of occurrences of each letter. Then they multiplied by it together. Then they subtract. They keep going. Yeah. That's what they did. This should be while k is greater than 0, though. How did this work? Because if their k becomes negative, I don't know how that worked. Yeah, I don't know how theirs thing worked. If my k becomes negative, this might break. You have k negative with a positive would always choose negative. Negative times negative. This will get you greater. I don't know. But for them it worked. So yeah, that guy is. Your codes are so short. So this one makes more sense. You know, while k is greater than or equal to it. Yeah. So yeah. How much time do I have left? It's only been 2 hours. Wow. That's crazy. Do I have time to do one more? Problem A. Do I have time? Let's try. We are going to attempt. There was an attempt. Okay. So we need some ingredients. He's going to create a supermarket. Unfortunately, there's only $S for sugar. That's not sad to be sad. There are N types of sugar. He wants to buy one, but not all. So he has, what the heck, 90 unusual politics. Instead of cents, you give sweets to buy a change. What? Number given sweets doesn't exceed 99 because each seller maximizes the number of dollars in the change. I don't know what that means. Okay, well, the tag said brute force, so maybe what is brute force? I'm going to get some water. Okay, back to this problem. Actually, I don't think we have time to do it because we only have 3 minutes left and Codeforces, it may be unavailable. What does that mean? Should we keep trying? I don't know. I don't know what that means. Okay, let's see. S stands for sugar. Read an N and S. N, read an N and S, read an X and Y. Okay, so how big is N? That's 100, so I could use an int. How big is S? That's 100. Okay, so then now we're gonna go here. We're gonna go here. And we're gonna read in X and Y. X and Y. X and Y. Okay, so back to this. Print the maximum number of sweets you can buy, or -1 if you can't buy any. Okay. N types sugar in the supermarket. Maybe he able to buy one, but not all. The supermarket has very unusual exchange politics. Let's see. I don't know. How to improve DP? I still have trouble with DP. You have to practice more. That's probably it, basically. So DP boils down to practicing. Just like how you practice anything, you just have to do more DP problems. I have not actually been doing DP problems, so I wouldn't know that much, but yeah. If you want to practice DP, you just have to do more. Oh, well, we're still not down, so. Okay, we're back to doing this. Okay, so we have a party. We have a party. We have ingredients. Unfortunately, he has S dollars for sugar, but that's not a reason to be sad because there are N types of sugar. Maybe he'll be able to buy one, but that's not all. Sure, supermarket has very unusual exchange politics. Instead of cents, the seller gives sweets to a buyer as change. Of course, the number of given sweets doesn't exceed 99 because then that would maximize the number of dollars in change. Okay, so you want to buy one type of sugar, but you also want to maximize the number of sweets in the exchange. What is the maximum number of sweets you could get? Oh boy. Okay. Okay, so we want exchanges the number of sugar. Here's the thing is that if you exchange this way, let's see. How much time? It's only been 2 hours and a half. It's been 2 hours? I don't know. The reason why I'm solving problems for 4 hours is because I have not been solving problems in ages. So this is a good way to, keep my mind mentally sharp. Also, let's look at Code Visualizer. So if you guys want to track your number of times you solved or submitted something, you could go to Codeforces Visualizer, and it actually keeps track of the days that you solved. So last month I've been getting really into it. In June I got very into it, but currently last 2 months I actually have not been solving that many problems. So in August and July I have not been solving, but in June I was solving a lot. So that was something. But yeah. keep in mind, just because you solve a lot, there's a few ways you could do it. Let's see. How many? So I've been solving a lot of. So I did solve a lot of A's. Trying to improve. I want to improve my 1,100 skills back up. So if I get this number to be to 80, then I'm more likely to solve more problems. I could get back to green. But yeah. Anyway. Okay, so for change, he doesn't want cents. Change, you get sweets. So if I do I have S dollars. Hold up. S dollars, I could buy the fourth type of sugar. 1, 2, 3, 4. Why does he do fourth type of sugar? Okay, I got it. Okay, so we're gonna have an array representing a pair of each X and Y. So this is representing the, I don't know, cents and costs. I don't know, max, num. No. Data, D. Let's put D, okay? D dot pushback X, Y. Okay, pair X, Y. Okay, so now what we're gonna do is we're gonna loop through from I is equal to 0, I is less than n, I plus plus, and then we're gonna pick each one. Can we pick multiple types of sugar? He needs to buy ingredients. She wants to buy only one type of sugar. We want to maximize the number of sweets. Okay, so then we just go through each of the sugar and then maximize the number of sweets. So we could do that by going through. So we go through the array again, D of I. So D of I is dot first is the my gosh. The dollars, D of I is dollars. So if I go through here, I have 5 pays $5. No, not 5. 1, 2, 3, 4. So $3, I get 90 cents, right? $3.90. If I have $10, I'm gonna divide 10 by 3, and that will give me the number of times I could buy it, which would be 3 with remainder 1. Do I need? So I cannot buy. The change is. It might be better if we convert everything to a double. And then do it. Because then we could use the cents, the remainder of the cents, and then use that as the sweets we could buy. You know what I mean? Like if I do 10 divided by 3.990, right? So if I do 10 divided by 3.90, it's going to give me 2.564. So I could do 2 times 3.90, 7.8, which would give me 10 minus 7.8. Give me 2.2. So that means I get 20 cents remainder if I pick the first one. So I have 20 sweets. Then I got to do the rest for 12. 12 is impossible. You can't do that. 10 minus 9. So you got 1. Yeah. He doesn't want to minimize the number of sugar. Yeah, okay, maybe we'd make it into a double is better. So let's make it into a double. So let's see, let's think. Yeah, it's actually better if we make it into a double. We're gonna take x, we'll take y divided by, so this is actually gonna be double. D dot pushback, we're gonna do cast this to a double. And then what we're gonna do is we're gonna take x plus y divided by 100. So y divided by 100 dot 0 to make it double. Then let's cast this to a double also to make sure it's forcibly into a double. And now we have the double. Now we're gonna take we'll go through D. We take s divided by d of I. S is an integer, so let's make this, we might make both of these doubles actually. Let's make s a double. Actually, integer divided by double is integer, I think it is. I don't know. Okay, so this is going to be like the remainder times you could divide by. And then we'll take s minus times d of I to get the remainder, right? So yeah, so this is going to be candies, right? Sweets. Then we want the maximum, so let's do like we need like a maximum 0, and then we do maximum is equal to max of candies, and then max num. We could do that. I think this would work. I don't know. At the end, if you can't buy anything, let's say you can buy anything. So like, let's say it was like 5, and then it was like 10. Oh crap. Wait, okay, so we have to check if s is greater than. S is greater than d of I, then you could do it. Otherwise you can't do it, right? Yeah, okay. Check if this condition was inside here, so let's do like Boolean pos false. Pos is true. If pos is equal to false, then we see out -1. Otherwise, we'll see out max num. Okay. So let's look at this. I got 4. That's not right. That's not right. Oh, we need a remainder. Okay, so damn. Okay, so number of times you can do it, you multiply by the value. Then you take this. This should be a double. Now I need the. Damn. Okay. So this is the remainder, which is like, let's say it was like 2.10. I need to get the actual like last 2 decimal places, because then that would be the actual candies. So I need to take the last 2 decimal places of candies, and that'll be my max num. So I need to take get last 2 tens and hundredths place of double C++. That's not what I want to do. I don't want to do another code. Digit extraction. Yes, that's what I want to do. Another thing we could do is see, I want the hundreds and tens place, but I don't want the I can multiply by 100 and then get the ones and then the tenths like that, but that's gonna be get like the individual digits. Yeah, I'll do that. So I'm gonna multiply candies by 100. So I'll do like candies multiply. Let's do like integer is equal to actual leftover. It's gonna equal to candies multiplied by 100. And then now what I'm gonna do is I'm gonna get the last two digits. So to do that, I'm gonna mod by 100. So if I have 2.30 multiplied by 100 is 230. Mod by 10 would get me 0. Mod by 100 would get me 3. No. Mod by 100 would get me 3. Oh, okay. So I get it left over mod by 100. Yeah, I could do that. Why is this not working? Oh, it's a double. Yeah, so this should work now. Yep, I got 50. It should be -1. Yeah, okay, so let's submit this and see if it works. Ah, damn. Damn it. Codeforces stopped. No. When is the next time it will go bad? 7:30. Ah. Okay, guys, I have to think about how we're gonna continue this live stream. It's only been 2 hours, so no. I would say Codeforce is not a good way to do interview prep. So people who are good at Codeforces, Asher, are good at interviews because they're really good at algorithms, right? But Codeforce is way harder than an actual interview. Like the problems you get on Codeforce is way more difficult, and like it's more hard to think about it. So in terms of your case, if you're having an interview, like let's say you have an interview with like Microsoft or something, right? You should do problems, previous interview questions from Microsoft. So you should do like search up like common LeetCode Microsoft interview questions for like on LeetCode and do those problems instead, because more likely those are going to be hashed out, right? If you don't have, yeah, because more likely those are the kinds of questions that they'll be asking you, right, on LeetCode. You should not be doing Codeforces to prepare you for your interviews, because Codeforces is way more hard. It's more complicated, right? It's not. It's kind of like doing. It's like saying like. If you want to, I don't know how to say this. Let's say you have a race coming up, right, where you have to run 100 meters, right? But instead of doing sprints, you're gonna run a marathon. You know what I mean? Like a marathon is more like intense, and maybe some people who do run marathons are good at sprinting, but that doesn't mean that you should do that if you have like a sprint race coming up, right? You should be tailoring to whatever you're doing, whatever your preparation. So if you have an interview coming up, definitely do leak code. Do leak code better. That's way. It's more likely to occur. But people who do competitive programming, they're good at interview questions. That's for sure, though. You could look up. There's a lot of people who are very good at interview questions, because they could. If it's like saying like people who win IMO for math competitions, right? Like they're very good on the SAT. They could get an SAT perfectly, right? But if you're studying for the SAT, are you gonna do IMO math problems? You know what I mean? Are you gonna do math Olympiad problems? No, it's not a good idea. For the next, like if you're taking the SAT in two months, I think it's better for you to do SAT problems, right? Instead of doing IMO math problems or like math Olympiad problems. Like it's better for you to do that way for preparation. You know what I mean? But yeah, if I had an interview coming up the way, I would definitely do leak code or interview cake. Or I would do like some other interview problems. I don't know. Those type of things. But I would definitely not be doing Codeforces. This is fun though. Codeforces is fun. It's kind of like you're competing with each other. That's what I like about it. Also, it's like way harder. It's hard to conceptualize. But now, because of the technical issues, I can't even submit this problem. So I'm going to have to. What could I do? I mean, this solution seemed right. I'm gonna have to think. We could do Code Chef. Let's see. Data Structures Learning Series. Oh, mercy. Mercy. Linear data structures. Wow. They're really upping in these preparations.
Yeah, so I'm Arden. I've
Oh, they're really upping the preparations. Thing is that most people on Code Chef cheat though, except for the ones who do well on the. I don't know. Maybe I should do these. But then the thing is, I don't want to like. I don't know. Like I could do these problems, but. Kamehameha. Data structures learning. These are good problems. It's a good learning course. Did they change the Code Chefs? No. So okay, so they don't have like a. So what difference between Codeforces and Code Chef is like Codeforces ranks each number by like a rating based on your rating that you could solve. Code Chef doesn't do that. They just have medium and hard, so that's what makes it harder to rank up. But yeah, that's a problem. I don't know if I want to do Code Chef. We should do Spoj. Spoj is like most common algorithms. So if you use Spoj, let me sign in real quick. These problems are like the most common algorithm problems. Yeah, close the list of classical problems. So I've been doing a few of them. Back in high school, I was just playing around with competitive programming. I didn't. Okay, so I at the last year of high school, all I did was just screw around. I was like, oh, I learned a bit of C++, and I was like, okay, and not C++. I learned a bit of Java, and I was like, okay, I might as well just do a few problems. Then I got up to like aggressive cows, and then I was like, I give up because it was too hard. But yeah, but these problems are pretty standard. Let's do next palindrome. Let's maybe we could do the next palindrome. Why not? Let's do this. Let's do this. Okay. So I need to submit this solution, but I don't know how I'm gonna submit this until the thing doesn't work, and I don't want to break it. So I'm going to like. How do I? I don't remember what problem it was. Damn. That's a shame. That's actually a shame. Okay. Yeah, okay, guys, we're switching to Spoj. We're gonna do Spoj questions. Most common Spoj questions. It's a shame that I couldn't get to submit this problem. I don't even know what problem it was. Okay, whoops. I'm going to copy this and paste this into a notepad, and then I'll submit the notepad from there. I don't remember what problem this was, but it's something to do with candies and cents, so. Okay, let's do Spoj, because these are common algorithms. Okay, I do not tutor. I've not tutored before. Okay, so let's do, I don't know anything about tutoring. Is it, I don't know. First line, T, number of test cases, K integers K are the next given T lines. Okay, so we want to create a palindrome, right? Write the value of the smallest palindrome larger than K to output. Smallest palindrome larger than K to output. Okay, so. Okay, this is a bit hard. Okay, so we have T test cases. We're going to read in T. Okay, now what we're going to do is we need to output the smallest palindrome that is just larger than K. So we're going to read in, we're reading K. Okay, I'm thinking whether or not we should use a string. Okay, so let's look at this. So if I want to output the smallest palindrome larger than K, let's say I have 808. Wait, so 808 is a palindrome. So the largest one would just be the center of the digit plus 1. So I could do 818. So that will be the next larger palindrome. So smallest palindrome larger than K. That would be the smallest palindrome larger than 808, right? Larger than that. But here's where the issue when it comes. Here's a problem. I can't just take the middle number plus 1. Let's say I have 12. Largest palindrome would be 22. So yes, okay, so if it's not a palindrome, I could take the left side and add 1. Okay? So yeah, okay, so increase 1 by the count. But okay, so there's issues with this though. If I have 2, 1, 3, 3, how am I gonna get this? Right? If I increase this by 1, I get this digit by 1. Then I get 2, 2, 3, 3, and that's not right. That's not a palindrome. So if I increase try decreasing this by 1, then you get 2, 2, 2, 3. That's still not a palindrome. They decrease this by 1, 2, 2, 2, 2. So if it's not a palindrome, repeat this digit. We need the largest the smallest palindrome that is just larger than this, right? Do I just repeat the first digit? K is no more than 100,000 digits. Oh boy. I'm going to go over these problems. I'm going to go over SPOJ. I'm going to SPOJ for classical 100 algorithms, right? I'm going to do that. That'll be a new series, guys. SPOJ, classical 100 algorithms, classical 100 problems. But yeah. Next palindrome, back to next palindrome. This is tough. It's tough. Yeah, so I'm thinking about doing a series on greedy algorithms. I have a book called Algorithm Design. I might go over that. But greedy is just picking whatever's the most common the best optimal solution at that certain time. That's what greedy is. So DP is mostly about breaking subproblems into smaller subproblems. But at a certain point, it comes down to practice, right? Anyway, let's go back to this number theory question. We could do next palindrome. I don't know. Why can't I submit this? Work. No. So if it's already a palindrome, I could increase 1 by the middle. If it's not a palindrome, I could repeat the same first letter twice, like that many number of times the length. There's also other cases where this wouldn't work though. So, okay, so I have 2 cases. So if it's already a palindrome, so, oh, whoops. Sorry. So we have 2 cases. We have already palindrome, add 1 to the middle number. So if already, so if it's already, fine. Already, if it's already a palindrome, just add 1 to the middle. If it's, let's say it was 2, 1, 3, 3. Repeat the first number. What if I had like 1, 2, 3, 2, 1? Yeah, I'll just increase 1 for here. What if it was like 1, 2, 3, 3, 3? How are you gonna do that? Increase 1 here, you get 1, 3, 3, 3, 3. Increase 1 here, you get 2, 3, 3, 3. Increase 1 here, you get 3, 3, 3, 3, 3. So most number of digits, right? I don't know. Oh boy. Oh boy. So there's 9 digits. There's 9 digits. 9 possible digits. It's already a palindrome, just increase the middle one. If it's not a palindrome, Can I brute force every single one until I find a palindrome? That's not a good idea. You could do, okay, technically, you could keep adding 1 to the number. So like here, I could just keep adding 1 over and over and over again until I get to 3s. Until I get to a number that's a palindrome. That's very inefficient though. But let's actually brute force that real quick. So I could do let's do solved k of crap. No. String k. What are we doing a string? Okay. So technically, you could convert the string to an int to do like a long to int is equal to k dot integer. Convert it to an integer. How to convert string to an integer? Why don't I forget? ctoy. How to convert string to an integer. I don't want to do that. S is scanf. I don't want to do that. stoy. stoy. So I could use stoy and use. Okay, so now I could do while not palindrome. To int plus plus. Right? And then I pass this number into. Right? And then I just print out to int. So I have a function called Boolean palindrome that takes in an integer. Let's say x, and then I converted it to a string. So let's convert number to string in C++. 2 underscore string, and I put in 2 underscore string. And then I check if it's a palindrome. This is the worst case I've ever possibly seen. So this is how you check if it's a palindrome. You loop through the second and then do s at I. If s at I is not equal to s at I minus s at length, so I need to take the length. Go to the middle, check if it's equal to the last value. So it would be s at length minus I, so 0 minus 1. Return false, otherwise return true. Okay. So this is totally brute force. But I think it would definitely work for the first two cases. So if it was like 808. Ah, damn, that's not right. Okay. We need a do while. Change this to do while. First time I've ever done this before in a while. So then it runs first. So we got 1, 808 Yeah, so that does work, but then we also have to check. Does my social circle code, or is it just me? I have friends that most of my friends are comp sci majors, but they don't really code by themselves. They don't do competitive programming, and they don't do. Yeah, so this is right. They don't do like, they just don't, they don't practice. There was one of my friends did get into Amazon, but he got lucky with his interview question. So, yeah, his interview question wasn't that difficult. Let's see if this works. I'm pretty sure I'm gonna get a. TLE. Runtime error, what? How did that happen? 0? Did I divide by 0? I never did that. Wait. Pretty sure my check palindrome is right. No, I don't want to do this way. I don't want to do that way either. You're doing one for loop, I'm pretty sure. Yeah, this is what I was doing. Pretty sure it's length over 2 though. Oh boy. How did I get a runtime error? How did I get a runtime error? Okay, because we got a runtime error, what we're gonna do is we're gonna try to find a different way to do it. So originally, if it's not a palindrome. I got it. Okay. So if it is a palindrome, we just take the middle number, add 1. Okay? Take the middle number, add 1. If it's not a palindrome, so let's say it was like 1, 2, 3, 2, 2. So let's say it was like 1, 2, 2, 3, 2, right? Like this. It's not a palindrome. What do? We find the largest number. This case, this largest digit, and then we repeat that. So that'll be 3, 3, 3, 3, 3, 3. Okay? Because you can't do 2, 2, 2, 2. Yeah. Let's see. Do I have time to do another one? All right, guys. So I actually have to. I'm gonna go to get food because I'm hungry at this point. So yeah, I couldn't actually. I didn't. Maybe I'll come. I didn't actually solve problems for 4 hours with you guys. So I'm actually gonna stop for this live stream a bit, and then I'll come back and solve later on. Probably when Codeforce is back up. But yeah, this is not really solving Codeforce problems for 4 hours, even though I tried to. But yeah, I'm just solving. I was just solving problems. But hope you guys enjoy this video. Rate, comment, subscribe. I'm gonna come back after when I eat food. But yeah, I'll start a new live stream later.